Welcome to the official Onshape Tutorial Series. This is the Boxer engine, famous for its horizontally opposed design and unique power delivery. In this two-part series, we're going to model and animate this mechanism in Onshape, validating its kinematics. To guide our modeling, we have a complete set of technical drawings ready for you. Let me show you. There is the exploded view with the parts list. So we get the crankshaft, the piston heads, and the rods. Onshape allows to represent the drawings in the sketches used. So we got three basic sketches. The first one for the crankshaft, the second one for the rod, and the third for the piston head. You can equally find the measurements of the solid parts. You can find an overview of the assembly with the initial offset and the distances between the piston heads. You have two options. First, you can follow along with me step by step as I present the model, or second, you can access the technical drawings, which I linked below, and work through the design process yourself. I will start my design with a sketch on the front plane. Press N, normal view to that, P, hide all planes, C, circle with 48 millimeters, a construction line going to the left with 96, another circle with an equal constraint between those two here. Then I will offset that circle to the outside with an 8 millimeter distance. I'll make those two construction geometry, go to the slot command, pick that line, give that a dimension of 112, then just attach another circle here, go to the 3-point arc, pick that origin, catch that horizontal constraint here, that vertical one, draw a line to that midpoint here, give that 122 dimension, and mirror over that construction line those two sketch lines. That's it for sketch number one. I'll go into the first extrude of these three, and I want to work going in the Y direction. I'll go backwards 22, make that sketch visible again, extrude that pin again with 22, and that circle with 8 millimeters. I'll assign a fillet to these four edges with a value of 22 millimeters, and another fillet of 2 millimeters to these edges here. I won't take that one here. I'll deselect that. Then make a mirror of that part over that mirror plane. I'll make a linear pattern of that part. Direction can be defined by that cylinder here. I'll give that 146 with 4 instances. I'll continue with the next sketch, just projecting that circle and extruding that 58, but for now as a new body. I'll pick the transform command for those two parts of the crankshaft and rotate them around that axis by 180 degrees. Now I'll make a linear pattern, 5, and a distance of 146. Direction is this one. And finally, I will make a Boolean operation, and the crankshaft is finished. I'll hide that sketch number 1, define a sketch plane by the midplane option between those two faces here. I might just use that plane to have a section view. Start a plane here, start a sketch, projecting that circle and that one. I'll hide the crankshaft. I'll continue in that sketch with a construction line to the left with a 244. There I'll attach a circle of 28. Continue with a slot, and I'll just erase that dimension and make those two here equal. Now I will make that construction geometry. Now I'll use the split command to split that circle at these intersections. That allows me to keep the constraints of that geometry. I will extend these lines to that circle. And exit that sketch. Hide that plane. Show that crankshaft. Exit the section view. Go into the extrude as a new body. To face, I'll pick that one. And as a second end position, again with that other face. Right, accept that. And apply fillet of 36 millimeters to these edges here. To finish the part, I will just apply a chamfer 4 millimeters to these edges. I'll rename that rod. I will draw my next sketch on that plane number 1. I'll just use the intersection command to have the intersection of that cylindrical face and my sketch plane. I can hide the rod and draw a rectangle here. Apply the 28 dimension overall 148. Here 88. Then another rectangle. Pressing Alt allows me to draw a circle. I'll give that 4 millimeters. And then dimension of 6. And that's it. I'll go into the revolve. Pick those 3 regions, revolve that around that axis. I'll continue shelling that body with a wall thickness of 8 millimeters. And now I'll make the next revolve, removing that square. If I do a right mouse button click, I go to select other and can pick that face, rotating around that axis. I'll make a linear pattern of that feature. I just select it in the tree. For direction, I can pick that face, go into that direction, and make the distance 16, 3 instances. Accept that. From that sketch, I will take these two, go to up to next, and likewise for the other direction. I'll rename that piston head. Change the appearance. Go over that face, which is the pin of this, and apply an appearance to that one as well. So that's for our 3 parts here. And that's it for sketching and modeling. I'll go into my first assembly, which will be a sub-assembly. I'll rename that sub-assembly rod piston. Insert those 2 parts here, which are free to move. And I will assign just one Revolute mate with that mate connector and the one in the middle. If I press Shift, I can select it with these. So that's our sub-assembly. And I'll start another assembly here. The main assembly. First of all, I will define one mate connector. I want the crankshaft in this position along the y-axis. So I will rotate that mate connector by 90 degrees around the x-axis. So I'm going to move, rotate around x by 90. I'll insert that crankshaft here and take the Revolute mate, hovering over that edge and our defined mate connector. I'll rename that Animate Me and just look at what that does. All right, it revolves. I'll hide that mate connector here. And now I want to insert my sub-assembly. And this again with a Revolute mate between this edge, or this mate connector defined by that edge, and that one. Okay. I'll rotate that to the position I want. And measure the distance between that face here and that center point, which is 102. All right, I will assign a variable with that name, offset. So that value is 102. And I'll assign one more, measuring the interval between the entities. I can take that face and that one, and I got the 146. So it's an interval of 146. All right. So this helps me for the definition of the slider mates. So I take that edge. I see that my x-axis is going in that direction. And I want this to be connected to one mate connector. Okay, I need to define that. So I go to that origin and move by rotating around the y-axis with 90 degrees. There it is. I'll hide the crankshaft for a moment so you can see that better. That's the mate connector I'm talking about. The z-axis going in that direction. Okay. So now back to that slider mate. Take that edge, take that mate connector, offset that by that initial offset value. Go to solve. It goes to its position. I can check on the animation. And that is what I want. Great. So now let's explore one very nice feature in Onshape, which is the replicate. This allows me to take one instance, like that sub-assembly, and find, just by picking faces, corresponding positions. So I will fix that crankshaft for a moment, ignoring that error message, because I just want to move those over there, because two sub-assemblies will work in that direction. Okay, I'll unfix it and define my next slider, picking that face, And now let's have a look. That is defined by the x-axis going towards my origin. So I need to offset that multiplying by -1 times that initial offset plus that interval. Okay. I'll continue like that with the third one, and the mate connector offset this time is -1 times offset plus 2 times interval. Okay, one last time for this one and the mate connector. Offset is -1 times offset plus 3 times interval, right? 1, 2, 3 plus 3 times interval. Accept that. Go to solve. Okay. And now let's check on our animation. That'll be a loop. I'll make it a little fast. 26. And there we get the animation of our boxer engine. So we've nailed the kinematics, but can the parts handle the power? Join us in part 2, where we take this design into the static FEA simulation to test the connecting rod stress and validate our material choice. Before you go, drop a comment below and share any questions you have about the modeling process. I'll be reading all your feedback and addressing your questions at the start of part 2. Don't forget to subscribe to the official Onshape channel for part 2 and use the link in the description to start your free trial of Onshape Professional today.